Hey everyone. So today we are talking about Lewis structures. If you remember, Lewis structures are these guys, right? They show us like the molecular representation of an atom. Okay, it could be that, it could be carbon dioxide with some lone pairs. Oops. Okay, so we're gonna learn how to draw these again. Now, today's process, it's just a good introduction into this. After today, we will no longer do this process to draw Lewis structures. I just think it's a good intro. It gets us back into the swing of things, helps us remember how to give our lone pairs and what atom needs to be the central atom. But after today, we are no longer doing the process that we learned in honors chemistry. We'll be using formal charges, which we'll talk about tomorrow. So let's remember how to do these Lewis structures. So let's go ahead and say that we want to do CCl3. Let me change my mind here. Let's do CHCl3. So we want to draw the Lewis structure for this molecule, this compound. What we do first is we count up the octet and duet electrons. Remember, everything follows the octet rule except a few exceptions, right? Hydrogen likes to have 2. Beryllium likes to have 4. Boron likes to have 6. Everything else likes to have 8, okay? But tomorrow, that's going to change. Pretty much once you get below the third period, everything can have more than 8, okay? Especially xenon. He likes to have more than 8 as well. But for now, hydrogen likes 2. Everything else likes 8, except beryllium likes 4 and boron likes 6. Okay, so let's go ahead and let's count up our octet and duet electrons. Carbon follows the octet rule. Hydrogen follows the duet rule. Chlorine follows the octet rule. And there's 3 of them. So we go ahead, we add all these up. 10, 18, 26, 34. Okay, so we have our octet and duet electrons. Next up is our valence electrons, right? Which is just what column they're in. Hydrogen is 1, beryllium's 2, 3, 4, 5, 6, 7, 8, and so on. That's how many valence electrons they have. Okay, so let's count those up. Carbon has 4, chlorine has 7, hydrogen has 1. So carbon has 4, hydrogen has 1, chlorine has 7. So we add all those up, 21, 22, 26. Okay, so we add up the octet electrons, we add up the valence electrons, and then we subtract them from one another, and we should get 8. That's how many bonding electrons we have. Well, we divide that by 2, and that tells us we should have 4 bonds. Okay, so now let's set up our atom, right? We got to put one of these guys in the center, okay? It's usually the ones that are by themselves. Well, we have 2 atoms that are by themselves, but remember, hydrogen can never be a central atom, ever. It's never going to be a central atom. Never put it in the middle. If you put it in the middle, I'm going to be really upset. Okay, so this time, carbon's going to be in the middle. And then we'll just go ahead and surround it by its surrounding atoms, right? We have 4 bonds, so 4 atoms to the outside, bond to each of those guys. And now we have to make sure that everybody's happy and everybody's duet and octet is filled. Hydrogen, right, is surrounded by this bond. Remember, this bond is 2 electrons. So hydrogen is surrounded by 2 electrons. It is happy. Carbon needs to be surrounded by 8. It follows the octet rule. So it's surrounded by 2, 4, 6, 8 electrons, right? These guys are shared. So it's like hydrogen has 2 and carbon has 2. So 2, 4, 6, 8. Carbon is happy. But chlorine follows the octet rule, right? But right now, each of those chlorines are only surrounded by 2, 2, and 2. So they're only surrounded by 2, so we got to give each of these guys 6 more. So let's go ahead and put 2, 4, 6, now 8, 2, 4, 6, 8, 2, 4, 6, 8. And now that's a happy molecule. Okay, that's our Lewis structure. Always double check. We should have 26 valence electrons, okay? Which if you count up all the electrons, you should get 26. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We're good to go, people. Okay? We are good to go there. Let's go ahead and let's do another one. First off, polar or nonpolar? Polar, right? There's an uneven pull here, right? If this was a chlorine, they'd all pull with the same strength and it'd be nonpolar, okay? But since we have a hydrogen here, these guys are going to pull with a stronger electronegativity. This guy not so much, so there's going to be an uneven distribution of electrons here. So this guy's polar. Let's go ahead and look at N2. Right, let's count up our octet and duet electrons. If we go up here, nitrogen follows the octet rule. It's not in this column for 6, this column for 4, and it's not hydrogen. So it likes 8 for today. It'll always like 8, honestly. It's not below that third period, so we're good. So we got 16 octet or duet electrons. Valence electrons, nitrogen likes 5. So let's do 5 and 5, which gives us 10. Subtract them. 6 bonding electrons divided by 2, that means we have 3 bonds. Okay? So we have nitrogen, and we have 3 bonds. Well, there's only one place for me to put those bonds. Right there, guys. Okay? Strongest bond, okay? But it's also the shortest bond. Single bonds are the weakest bond, but they're the longest, okay? And then double somewhere in the middle. So triple bond, but it's also the shortest bond. Okay, so nitrogen needs to be surrounded by 8 electrons. We got 2, 4, 6 shared between these two. So each nitrogen has 6 right now. So we got to put a lone pair on each of those guys. So now that they have surrounded by 8, surrounded by 8. Let's count up our electrons and make sure we have 10. 2, 4, 6, 8, 10. We're good to go. Polar or nonpolar? We look at this guy, nitrogens, they're both the same, right? So they're going to pull with the same strength. So that means there's not going to be a dipole moment, a misdistribution of electrons. So this guy is nonpolar. Okay. Let's switch it up a little bit. Let's go SO4 to negative. Actually, let's not do that right now. That might lead us into tomorrow's stuff. How about we do NH4 plus? Let's do that guy instead. That sounds good. Okay, so let's go ahead and let's do NH4 plus. Let's count up our octet and duet electrons. Well, nitrogen follows the octet rule. Hydrogen follows the duet rule. For them, we add all those up. We should get something like 16. Valence electrons. Nitrogen has 5. Hydrogen has 1. 1, 2, 3, 4. So that would be 9. But wait, remember, if you see a plus sign, you get rid of a valence electron. Okay? If it was a minus sign, you would add a valence electron. So say we had Cn minus, we would add a valence electron. And we'll do that one next. But since it's positive, we subtract a valence electron, so we only have 8. So we'll have 8 once again. And you know something was wrong when you put 9 down here and you're like, oh, wait, that's 7. 7 divided by 2 is 3.5. I can't have 3.5 bonds. I must have goofed up somewhere. So we'll put 8 right there. 16 minus 8 is 8. Divided by 2, we're going to have 4 bonds, people. Central atom. What's going to be my central atom? It's going to be my atom that's by itself, okay? If you ever get in a situation like, say, CNO, okay, where you have to do the Lewis structure CNO, this is a side note, by the way, usually the one that's least electronegative goes in the center. So between CNO, they're all by themselves. If we were to make the Lewis structure, the C would go in the center because it is the least electronegative. That's just because if you're more electronegative, you want to attract electrons. Well, you're going to attract electrons if you're on the outside of the atom, like so, right? You're going to attract more of those electrons if you're on the outside. The only exception to that is hydrogen, and that's just because it could only be surrounded by 2, so it could only go on the outside. So if you're in a situation where you have to make a decision between two or more atoms, which is going to be the central atom, always pick the one that's least electronegative. Back to where we were. Nitrogen's in our center because it's by itself. Hydrogen's on the outside because they're never in the center. 4 bonds. 1, 2, 3, 4. Okay, let's make sure everything's got their rules satisfied. Hydrogen's duet rule. They're each surrounded by 2. Nitrogen is the octet rule. 2, 4, 6, 8. They're happy, and it matches our 8 valence electron, so this is good. And then when there's a plus sign, we'll talk about this with Lewis structures, list that it is positive. And we'll talk about that tomorrow. Okay, let's go ahead and do Cn minus, and we'll be done with Lewis structures. By the way, polar or nonpolar, this guy is nonpolar. It's got no lone pairs on the central atom, right? All the atoms on the outside are the same, so they pull with the same strength. Nonpolar, nonpolar, polar. If we're in a situation with H2O, is that going to be polar or nonpolar? And the answer is that's going to be polar, okay? Because it's got lone pairs on the central atom. Yeah, they're pulling the same strength, these hydrogens, but those lone pairs mess everything up and shift our hydrogens downward to make it an uneven pull. So whenever you see lone pairs on the central atom, you're thinking polar as well. Let's do Cn minus and let's get out of here. Okay, octet and duet rule, carbogen and nitron, both follow the octet rule. So 8, 8, 16. Carbon has 4 valence electrons. Nitrogen has 5. Okay, you would know something is up if you went minus there. You'd get 7, and you'd have 3.5 bonds. That's not cool. But since we have the minus sign, remember we have to add 1 more valence electron. 10, 16 minus 10 is 6. Divide by 2, we have 3 bonds. That's the only way we could do it. Polar or nonpolar, we're thinking polar based on our rules. Fill the octet. Right, 2, 4, 6, 8, 2, 4, 6, 8. Around each one, we need 10 valence electrons, 2, 4, 6, 8, 10. Okay, so that is Lewis structures, everybody. We're not going to get into the shape and bond angle yet. We'll do that later on. But remember, after today, this process is gone. It's a good foundation. It helps us kind of see how Lewis structures are laid out. But tomorrow, we'll be talking about formal charges, and we'll start getting into these elements down here that could not obey the octet rule anymore. Okay, so that is it for today. Have a great one.